energy, the difference in the energy is between the first Lyman lines emitted by A and B. Okay, delta, first we'll calculate that delta E. So this will be 13.6. Because a hydrogen-like atom, 2 square minus 13 point. This is what he has given electron volt. No, this is. Why negative sign should be there? No, the difference in energy levels is what he has given. First line of the energy of the first line Lyman series of the B minus the particular difference is what we are taking. So this should be equal to 81.6 electron volt, 13.6 electron volt. This should be equal to 1 minus 1 by 4, 3 by 4. Bracket term 3 by 4, bracket common, ZB square minus ZA square. What is all everything? So we should calculate the atom A and atom B. What are that atom A and B? Then again, after getting the value of Z, the charge of the nucleus, we can come for the second one. First line of Balmer series. So somehow we should calculate this ZB and ZA. I have one equation. Okay, this how much it will be? 816 by
8, sir. ZB square
8.
minus ZA square equal to 8.
Okay, yeah, fine. Okay, this will be much easier. Huh? I need one more equation getting the relation between ZB and ZA. So I'll take help of that collision. Something is saying here when the atoms A and B are moving. Look at this last part of the data. Same velocity. So atom. So this will be MA. It is moving with a velocity U. It will collide with the heavy target. So this heavy target is there. And they rebound back with half of the speed. How to, this one, the target will have certain mass, mt. It will impart a momentum and this will, okay, the initially it's at rest. Huh? So then finally it will be motion. It will rebound with half of the speed. I think this is if I write u, so this will be u by 2. Masses are, so again for the second situation, the second nucleus moving with a speed u, which will strike with a target, and the target is at rest, and it will impart momentum, that will be v2. What is one last part? Our in the process, atom B imparts the target a momentum which is 3 times the momentum imparted to the target. So any relation between V2 and V1. V2 should be equal to 3 V1 from the last data. Okay, let me write conservation of momentum equation. So MAU should be equal to MTV1 minus MAU by 2. So this will become 3 MAU by 2 equal to MTV1. Then similarly, MBU equal to MTV2 minus. So this also equal to 3 by 2 MBU is equal to MTV2. Now comparing these equations, V2 equal to 3 V1. So MB should be equal to 3 times of MB. So from MB is equal to 3 MA, I'll get it. And then what is the other condition he has given? Are of different masses. They are of different masses, and each atom has ratio of neutron to proton equal to unity.
MB equal to 2 into ZB, MA equal to 2 into ZA.
What all that mass will be there, number of protons and neutrons must be equal, but since they are of different masses. So if suppose say if this is having, if this nucleus is having 1 proton, 1 neutron, what about this? It should have 3 protons, 3 neutrons. I think that's what the relationship, no? Since number of protons, if as n equal to z, I will bring the data here, no? As n equal to z for both the atoms, Therefore, what we can write it as ZB is equal to 3 times of ZA. Am I right? I think you have
Yes.
to. So best thing is I think I feel like if you assume if you assume like an atom A is having 1 proton, 1 neutron, then what about the atom B? Should have 3 protons, 3 neutrons. So therefore, the charge of nucleus of atom B should be 3 times that of charge of nucleus of atom B. So this is the equation 5. Solving now, I'll get the ZB and ZA.
A is
Need a-
deuterium and B is lithium.
A will be deuterium. Huh?
Yes.
Yes, sir.
So atom A will be deuterium. Atom B will be lithium. Huh?
Not lithium mass will be 7 no sir.
Lithium,
Sir, according to given conditions, 3 Li6 only.
yeah, Li36 will come.
Yes sir.
I'll write it. Okay, this will be lithium. Isotope, it can be possible, no?
Second question 15.1 electron volts.
The difference in energy between the first Balmer lines emitted by A and B. I think here we'll go for definitely. Balmer line means what we can take 3 to 1. 3 to 1. Okay, the value of ZB is there. The difference in energy is between the first Balmer line emitted by this one. Here I'll write 3, here I'll write 3, and the value of ZB and ZA we know.
3 to 2 sir.
First Balmer.
Yes sir.
Yeah, okay. Second line of first Balmer line, 3 to 2. I'll take the same equation. Copy. The second part, 3 to 2. How much you'll get?
15.1 electron volt.
15.1. You check it. I think this is some advanced. They preferred questions of these kind also. So usually what happened, we have our books open, we confined ourselves to only hydrogen atom with no neutron. Am I right? Only proton, 1 electron, charge of that one. Inside the nucleus, we are just assuming that 1 proton is there. But even possibility is not going for the complete atomic structure, but still. Let me take the next one.